Okay, so hi there everybody. We're now on our next video in the introduction to statistics. And this video we're going to show and we're going to start with the testing the hypothesis when it comes to significant relationships. So we're going to test this using our Pearson R value, and then we're going to make use of some p-value here, that is the t-test actually. And then we're going to know if there's a significant relationship between two groups of data. So we're going to look at this example here. This example is 10.4 formally. So construct a scatter plot for the data shown for the car rental companies in the US for a recent year. So what we're going to do is test the significance of the relation of the coefficient correlation found in example 10.4, and we're going to make use of alpha of 0.05. So first, let's go back to our basics and correlation. What we're going to do here, as instructed, we're going to construct the scatter plot for the data shown for the car rentals. So how do we do that? We're going to highlight this and then go to Insert tab and click on this scatter plot. Click this, the first scatter, the XY, and then it will pop up the scatter plot over here, somewhere in this Excel, and it can give you this kind of structure here. So if you want, you can get the regression line or the best fit line. You can just do the right click, add trend line to that, and you can add some linear line. And we want to display the equation on chart and the R squared value on chart. So that's what you get if you want to get the best fit line of this given data. Now, what we want to answer, we're done with the first instruction. What we're going to do is to get this test of significance or test the significance relationship. If you want, we can also get the Pearson R value. If you only want the Pearson R value, go to the data and click on data analysis here, and we want to choose correlation. Click OK. And then just for the input range, I want to input all of these, including the labels. So I will want to check the labels here in the first row. I group them by columns as you can see, and I want my output to appear over here. Okay, so let's click OK. It will pop up the value of the correlation, the Pearson R, which is 0.9819. So that's a strong positive relationship between the cars and the revenue. So meaning as the cars get higher, the number of rental of the cars get higher, so the revenue increases. So we want to check if there's a significant relationship. So maybe it's only due to chances that there's a relationship that occurs, but we want to make sure that it's significant. So we can do this in the four-step manner that we always did. So what that we always do. Step one will be writing the hypothesis. Step two will be the p-value. Step three will be the decision rule, and step four will be the writing of the conclusion. So let's start with step one. We're going to say p sub o, or rather h sub o, your null. We're going to make use of the Greek letter rho here, p. Okay, or if you want, if you're really strict with the Greek letters, you can just search row here, and I think it will appear this one there. So since again our null says that there's a status quo, there's no difference, so we can say that your row is equal to 0 for your null. And for your alternative hypothesis, let me copy this row here. We can say in your alternative, your row is not equal to 0. Okay, so meaning there's a significant relationship. Okay, h sub o here now tells that there is no significant relationship. So that leads us to step two. In step two, what we need to do is to go back in data. You want to choose again the data analysis, and instead of correlation, since the information in correlation only tells us this Pearson R only, we want to go to the regression, and we click OK. We need to input the X and Y value. We should be very critical with that. We should know what is the first range and the second range. So the input Y will be the effect, you know. So after getting the car rentals, there should be a y value, which is the dependent variable, which is your revenue. So the number of cars, the revenue depends on the number of car rentals. So that's your x, your car rentals. We want to put the labels on the first row. We leave the others be. Output range, we want to put the output here. Okay, and then that's all that we need actually. So we just click OK. All the others if you want, so you can choose to put it there. So that's, as far as p-value is concerned, that's what we need. So we have here a bunch of numbers that we can get. Actually, your multiple R value is similar to your Pearson R here. So as you can see, so they're the same. So multiple R just simply says, or gives you the information about the 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 um the the strength of the relationship. What we want is the p-value here in step 2, right? So we can see that there's an ANOVA chart here, but we don't really need that ANOVA chart right now. um what we really need, we can see some words here which are, we can just adjust that. What we need is the p-value, and you can see here the p-value in this column here, and we want, actually, we want the p-value for the cars, not the intercept. We want the p-value for the cars. So this is what we're looking for, actually. So our answer here is 0.00048. Okay, so remember, whenever you're looking for the p-value using Excel, and we're going to measure the strength of the coefficient using Pearson R, we want to look at this p-value here. If you're using of the traditional approach, so the t-stat value will be the one you're looking for. So that's 10.39. So the p-value is 0.0004. So let's go to the step 3 already. I think I can fit it here, over here. Step 3. So step 3 is our decision rule. So we can see that since our p-value, which is 0.0004, is less than your alpha, I think that's quite obvious that it's less than your alpha. Your alpha is 0.05 over here. You can see that. Okay, there. So that is, you can see that 0.00048 is strictly less than 0.05. Hence, what we will do is that we reject the null hypothesis. So that's simply our answer for step 3. We reject the null hypothesis. For step 4 is now the conclusion. How do we say the conclusion? So since we reject the null hypothesis, therefore we're telling that the alternative hypothesis is the one that is true. Hence, what are we going to do? So what is the statement here? So we say that there is a significant relationship between the number of cars a rental agency owns and its annual income. Okay, so that would be the step number 4. Okay, so telling us that there is a significant relationship between the variable x and the variable y, that is your cars, and your revenue. So if ever you want to measure the significant relationships of any relationship of any variable, you follow this process, and pretty much you'll get to the answer, which is your p-value. Okay, so that's it for this video. Thank you very much for watching. Hope you'd like and subscribe. See ya.